Okay, we want to determine the area above y equals negative sine x from pi over 6 to pi over 2. So the two curves here, the area between two curves, will be the x-axis as the function above and y equals negative sine x as the function below. The equation of the x-axis is y equals 0. So we define our h of x as the function above, which is 0, minus the function below, which is negative sine x. H of x equals sine of x. The antiderivative is just negative cos x. So our area, left bound pi over 6, right bound pi over 2, will be h at pi over 2, subtract h at pi over 6. H at pi over 2, we substitute into our antiderivative, pi over 6, we'll do the same. And we need to evaluate this. Now both of these angles here are special angles. This one being 90 degrees, and the cos of 90 degrees is 0. So negative 0, so I'll just write down 0 here. Subtract. The cos of pi over 6. The cos of pi over 6 is 30 degrees. So let's draw our special triangle. This is 30, 60, 90 triangle. Opposite 30 degrees is 1. Opposite the 90 degrees is 2. And opposite the 60 would be root 3. So the cos of pi over 6 is adjacent over hypotenuse is root 3 over 2. So this will be negative root 3 over 2. 0 minus negative root 3 over 2 simplifies to positive root 3 over 2. So there is the exact area of the region R. Next example, we want to determine the area between y equals cos x and y equals sine x from 0 to pi over 2. So from 0 to pi over 2, these two curves cross over. So we have to split it up into two separate regions. R1, our h of x function would be, the curve above is cos x and the curve below is sine x, which would be cos of x minus sine of x. The left bound will be 0. The right bound, according to this picture, would be pi over 4. Now, how would you figure that out if I didn't give you the picture? Well, you'd have to intersect the two graphs. So sine x will be intersecting with cos of x. So you have to solve this equation. One way you can do this is divide both sides by cos x. And cos of x is not going to equal 0 in this interval, so we can do this. And that'll be 1. And sine x over cos x is tan x. With a calculator, you just take the tan inverse of 1. But without a calculator, you would write this as opposite over adjacent and draw your special triangle. And this special triangle is the 45, 45, 90 triangle. So the tan of x is, this angle here is going to be the 45 degrees. So x is 45 degrees, which is pi over 4, as we see in this diagram. So continuing back up here, we have h of x, the antiderivative of cos x is sine x. the antiderivative of sine x is negative cos x, but we're subtracting here, so we have plus cos x. So now, the area of region 1 would be, we'll call it this, would be h at pi over 4 minus h at pi over 2. And we'll substitute sine pi over 4 plus cos pi over 4. So that's the first part here, h at pi over 4. We'll subtract, we'll substitute pi over 2. I'm making an error here. This should not be that. This should be 0. So I have to correct that. That's h at 0. It's bounded to the right, pi over 4, and to the left, 0. Sorry about that. Sine 0 plus cos 0. These are special angles, 45 degrees, so that's 1 over root 2 plus 1 over root 2. Subtract, sine 0 is 0, cos 0 is 1, and we get, add two fractions here, 2 root 2 minus 1. There you have the area of region 1. Now, region 2, if you look at the diagram, there's symmetry here. Region 2 is the same as region 1. So we can determine both the sum of these just by doubling the area of region 1. And that would be a shortcut here. If you wanted to do it the long way, you'd have to redefine h of x, and this time the sine of x would be first minus the cos of x, and you'd have to go through this whole process here. You'd have different left and right bounds. You'd have pi over 2 as your right bound and pi over 4 as your left bound. But I'm not going to go through that. I'm just going to skip that and just write since region 1 equals region 2 in area, therefore the total area is just going to be 2 multiplied by that, 2 over root 2 minus 1. And that's your answer. And we'll leave it at that. You could rationalize the denominator here and then double it and simplify, but I think you guys get the point. This is your exact area for R1 and R2 combined.